Alright, today's video goes along with math worksheet or activity number 2-1 from Monday, August 24th. And we're going to be talking about slope of a line today as we start to get actually into stuff that's useful for pre-calculus, calculus, quantitative reasoning. All the dual credit classes will definitely cover slope and graphs. So the first thing we're going to look at is what is slope. It is the measure of steepness and direction of a line. So first off, we're just going to talk about direction right now. Alright, so the direction of a line, there's four choices. You could have a positive line. A positive line is any line that is going in the up direction from left to right. Now, obviously, again, we're not talking about the steepness right now. We'll get to that in a minute. We're just talking about its direction. And then a negative slope. Any slope that is going downward from left to right. Right. Then a zero slope would be any slope that is completely horizontal, parallel to the x-axis. And then undefined would be a line that's vertical and does not go left to right at all. Everything else has a left to right movement, so you might want to make note of that. Everything is left to right. And since this last one here, can't go left to right, that's what makes it undefined. So again, that's just talking about the direction of a line. What we really want to talk about is how to find its steepness. Steepness is the number that goes along with the positive or negative part. All right? So if we have a graph that's already pre-drawn, we can find the steepness of the line by finding 2 points on the line that cross at corners. And the purpose of that is to avoid fractions. For example, I do not want to choose this spot here. All right? Because if I choose that spot and this spot, and I want to count rise and run, how much up am I actually counting? It's kind of hard to tell because it's fractional. So I want to avoid that. And what I want to do is I want to find spots where the graph crosses right on the corners so that I don't have to count fractional spaces. Now when I do my second step and count my rise, so in this example, rise over run, my rise, I went up one space. Now anytime you go up, that would be positive. If I would go down, it'd be a negative. All right, just like the number lines are here. And then I needed to go to the right, and I'm going to the right 2 spaces. Since I went to the right, it was positive. All right, so I'm going to reduce that fraction down to positive 1/2. Now I want to double check. That's the third step. Double check the plus minus sign. If I have a positive slope, then that means this graph had better be going in the up direction from left to right, and it is. So I've checked. And if I had accidentally got negative 1/2 there, I would have known I was wrong, because by the picture it's clearly a positive slope. All right, so now we have the direction, positive, and the steepness, 1/2. That means up 1 space for every time you go over 2 spaces. All right, third way is to do it without a graph. Sometimes you just have the pieces of information, you don't have the picture. So to do that, we'd need 2 pieces of information. Those have to be points on the line. And the little subscripts, x sub 1 and y sub 1, those are kind of like last names almost for this first couple. They're the one family. That's a husband and a wife, I guess. X and a Y. And then the second group here, they're little 2s. Those are their last names. That has nothing to do with the work. That 1s and 2s in there don't mean anything other than, hey, these guys go together, and hey, these guys go together. That's all it means. All right? So the formula, y2 minus y1 over x2 minus x1, is where we're going to plug those numbers in. And essentially the y2 minus y1, what that's really giving us is called the change in y. That's our rise. How much did we change in y? How much did we go up or go down? A symbol that you're going to get used to if you're in calculus would be delta y, would how you would say change in y. Delta is just a triangle. But if you ever see delta y, that's what it means. It means what's the change in y as far as the slope. All right, so if I'm doing this example down here, it doesn't really matter if I call this the 1 family over here and if I call this the 2 family. Just don't mix them up. All right, so then that means I'm going to do the y2 number, which would be the 1, and then there's a subtraction in the formula that's always there. And then subtract the y1 number, which was 3. So that's going to be negative 2. That means the rise would be down 2, change in y. All right, now for the x's, the denominator, that's our change in x. I want x2, which is negative 1, minus x1, which is 4. That's going to give me a -6. Always reduce fractions. -2 and -6 will reduce down to positive 1/3. So we know its direction, positive. That means it's going up from left to right. And we know its steepness, up 1 for every 3 spaces you go to the right. All right, that is your work for today. Hopefully this was a good review, and yes, you will absolutely be using this throughout the course, even in AP Calculus. All right, hopefully you can understand this pretty well. Have a great day.